All right, good morning, Algebra 1 lab kids. We are going to do a little bit of work today, and we're still solving linear inequalities. So we're solving linear inequalities. All right, so today is part 2. And so in part 2, we are going to still be solving linear inequalities, but a few things might happen. So I want to first remind everyone, if the coefficient is negative, so if it is negative, we flip the inequality whenever we divide. So that'll just be on that last step. So that still applies. Now, today there's actually going to be some things that happen, and I'm actually just going to talk about them each one at a time. We're not going to write anything like rules down. But we are going to first do some problems where so there are 3 types of inequalities. All right, we can have a specific solution. That's what we did yesterday, where we get like x is greater than 3, or x is less than or equal to 7. So we get a specific solution. An example would be like x is less than 5. All right, so then we can also get answers that are no solution. And we'll do some examples of those today. And then we will have some that are all real numbers. All right, so the first one that we are going to do today is, and whenever you're solving these, they are going to look exactly the same. It's just at the very end, you have to make a decision. So the very first problem we are going to do today is a specific solution. Just like we did, it's just a little review. So we have -7, and then in parentheses, 4 plus 3x minus 2x is greater than or equal to -120. So just like we did yesterday, when we see parentheses, we're going to distribute. So we get -28 minus 21x. Then I'm going to bring down my minus 2x is greater than or equal to -120. Now that my parentheses are gone, I can rearrange. So these two are already on the left, so we don't have to do anything there except bring those straight down. And then we have our greater than or equal to symbol. Now we have on the right-hand side, the -120 is already there. But to move that -28 over, we're going to change it to a positive. And then at this point, you can use a calculator if you need to. -21 and a -2 would be a -23x is greater than or equal to. Then we need to take -120 plus 28, and that gives us a -92. All right, now, if we look at this, we are dividing by -23. So since the coefficient here is negative, when we write our final solution, we're going to flip that inequality. So we are going to have x, the greater than or less than will become, or greater than or equal to will become less than or equal to. And -92 divided by -23 would give me a +4. So that is a specific solution. It's talking about a specific number as a boundary line, and we're talking about all numbers less than or equal to 4. So that is an example of a specific answer. Now, I'm going to give you another example of a specific answer, but it just looks a little different. So this is another specific example. 8 times 5x minus 1 is less than or equal to negative 8 plus 5x. So first step always when we have parentheses, we distribute. So we get 40x minus 8 is less than or equal to negative 8 plus 5x, just bringing that down. Once the parentheses are gone, we can rearrange. So I want the 40x on the left, but I also want this 5x. So to move it over, I'm going to subtract it or make it a negative, which is less than or equal to. And on this side, we have a negative 8, but this 8 needs to come over, so we're going to add it. So when we combine our like terms, 40 minus 5 gives us a 35x is less than or equal to negative 8 plus 8 is 0. Now, our last step, we want to try to get x by itself. So we are going to divide by 35 because we have a coefficient to divide by. But when we divide, we don't flip because this coefficient was positive, so it stays the same. But when we divide, 0 divided by anything is 0. So it is okay to have a solution of 0. So this is telling us for this equation, we're talking about all numbers less than or equal to 0. So 0 and all the negative numbers. So that is an example of a specific solution, which just happens to be 0, which is totally fine. All right, so now we are ready for an example that is all real numbers. All right, so something special happens when you're solving this. So we have 1 minus v plus 6 is greater than or equal to negative v plus 7. So there's no parentheses, so we are ready to rearrange. All right, this negative v is already over here, but to move this one over, we're going to make it a positive. And then we have a 7, which is already on that side, but we're going to subtract a 1, and we're going to subtract a 6. Now, whenever we look at this, I end up with 0. On the right-hand side, I end up with 0. So if you end up with no variables, so if you see on that last example, we still had a coefficient with x. We no longer have a coefficient. It's just 0. So you have to ask yourself, is this a true statement or a false statement? Is 0 greater than? Now, this or equal to also makes it true. 0 is equal to 0, so this works. So if it is a true statement at the end, you're going to say that every number would work for this inequality. It doesn't matter what value we would plug in for the variable v. We're going to get a true statement no matter what. So true statements then result in a solution of all real numbers. Now, in all real numbers, you are welcome to use this symbol. It's a capital R with 2 stems. So this symbol means all real numbers. All right, so then we are going to do an example of a no solution, and I'll show you what that looks like. All right, let's do one like, we're going to actually do 2 of these. So let's do this one first. 8a plus 4 is less than 3a plus 5a. So we have no parentheses, so we are ready to rearrange. So we have 8a. Now, these are both positive, so when I move them over, because they have variables, I'm going to make them negatives. And then this positive 4 is going to become a negative 4. 8 minus 3 minus 5 is 0. So we have to ask ourselves, is this true or false? So on this one, is 0 less than negative 4? That is definitely not true. It is false because 0 is bigger than any negative number. So if it is a false statement, then we would write that our answer is no solution, or you can use this symbol, a 0 with a slash through it. So what we've learned, if you have no coefficient when you're solving, if all of the variables subtract to 0, that means if it is a true statement, we go with the all real numbers, or you, instead of writing that out, if you want to use this symbol, that's okay. If you get to the end and it is a false statement, we say that it has no solution because nothing worked for it. And we use this symbol, a 0 with a slash. I don't care if you write it out or use the symbol. All right, so I'm going to give you guys another example of a no solution that looks like this. Okay, it's a little bit more complicated. So on this left-hand side, we have no distributive property, so I'm just going to rewrite those. Bring down my inequality symbol of greater than. Now, I do have to distribute here, so negative 3 times 3x becomes negative 9x. A negative 3 times a negative 4 is a positive 12. Now, on this second part, I have to distribute a negative, which is like a negative 1. So negative 1 times x is negative 1x. Negative 1 times 2 is a negative 2. Now I can rearrange. So I have 2 x's on the left-hand side. I'm going to bring those down. Now this negative 9, I'm going to make a positive 9. This negative 1, I'm going to make a positive 1. Bring down my greater than symbol. Now over here, I have a 12 and a minus 2, so I'm going to bring those down. And then I bring over my negative 5 becomes a positive 5. So I'm going to combine. Negative 6 minus 4 is negative 10. Plus 9 gives me negative 1. Plus 1 gives me... So all of these combined together is 0. Because it's a negative 10 and a positive 10. Is greater than 12 minus 2 is 10. Plus 5 is 15. So we have to ask ourselves, is this true or false? 0 is greater than 15. So if we look at that, this is obviously the bigger number. 0 is not bigger than that. It is false. So a false answer would be a no solution. And again, feel free to use the symbol instead of writing all of that out. So those are all of the examples I have for today. I actually don't have an assignment for Thursday. We will be doing an in-class assignment on Friday. So just check in tomorrow. And if you have questions, don't hesitate to send me an email. I hope you guys have a great day.